Welcome back. I hope you had a great spring break. Today is Tuesday, April 14th, 2020, and we are going to be working on using slope-intercept form to solve real-world problems. Before we start talking about the real-world problems, I'd like to review a couple things. The first one is the equation for finding slope from 2 points, and the second is slope-intercept form. So let's start with the first one, the equation for finding slope. If you recall, the equation for finding the slope of a line from two ordered pairs is y2 minus y1 over x2 minus x1. Now, the common error that students make whenever they are using this equation and they have two ordered pairs is putting the wrong numbers in the wrong places. Okay? But as I talked about in class, there's a very simple way of making sure that you do this correctly every time. So, if I'm given these two ordered pairs, say I'm given 3, negative 6. And I'm given 2, negative 8. I have to determine which of these ordered pairs is the first ordered pair and which one is the second ordered pair. The reason is because this little subscript right here, that number 1 and that number 1 right there, those two number 1s represent the x and the y from the first ordered pair. So then guess what? These number 2s represent the x and the y from the second ordered pair. That's the only reason those subscripts are there. Okay? So, let's identify them. I have a tendency to make the first ordered pair that I read the first ordered pair. So that's what I'm going to do here. I'm going to say that this is ordered pair number 1 and this is ordered pair number 2. Okay? So this is number 1, this is number 2. What that means is when I'm dealing with my y values, which using blue to represent, that means that this is y2 because it's the y value in my second equation, my second ordered pair, and this is y1 because it's my y value in my first order pair. That means that when it comes to my x's, this is x2 because it's my x in my second order pair, and this is x1 because it's my x value in my first order pair. Doesn't matter which one you select. If you did it the other way around, then your values would flip-flop. But ultimately, when you do the calculation, you're going to get the same slope. I like to actually write mine down to make sure that I avoid any calculation errors whenever I'm substituting my numbers. Okay? So now, plugging the numbers in. In order to plug the numbers in, I need to make sure that I know where they are going. So here, I'm going to change back to black, make this a little smaller. This x1 value, that gets filled in there. So this 3 would be in this space. This x2 value would be here. My y2 value, my y1 value would go here. And my y2 value would go here. So let's plug in the numbers. If I'm plugging in the numbers, instead of writing y2, I'm going to write -8. And I'm going to put my minus sign. And instead of writing y1, I'm going to write in -6. But I'm going to put a pair of parentheses around my -6 because I have a subtraction sign and a negative sign right beside each other, and I don't want to get them mixed up. Now I'm going to put my fraction bar, and I'm going to find my x2, and that is a +2. Putting down my minus sign, and x1. x1 is +3. So now, a lot of times students get confused, but listen to this. Whenever you're adding positive and negative numbers, you have to think about the real world. In this part of this expression, I have -8 minus -6. So if I'm taking away a -6, that means I'm taking away something bad. That means that my value should increase. So taking away a negative is the same thing as adding a +6. So I'm going to rewrite my numbers: -8 plus +6. And in the bottom, I have 2, and I'm taking away a +3. Well, let's think about that. If I take away something positive, my value is going to decrease. So taking away something positive is the same thing as adding something negative. I have 2. If it's going to write, let's see. Alright. Okay, let's see. Technical difficulties. Alright. It's erasing. So why isn't it writing? Give me a second. Let's see if I can make this work. +3. I wonder why that's not writing. Let's see. Did I? Let's see. Well, it's not the Apple Pencil, so I'm wondering what it is. Well, ain't this something? I'm not sure why this is. Alright, so that moves it around. Well, there we go. I want to undo that and change the color back to black. 2, and as I said, take away a +3 is the same thing as adding a -3. And again, I'm going to use my parentheses because I have a plus sign right beside a negative sign, and I don't want to get them confused. So as I go on, -8, I'm at -8 on the number line, and I want to move to the right. I'm adding a positive, so move to the right 6 times. That's going to put me at -2. I'm at +2, and I'm adding a negative, so I want to move to the left 3 spaces. If I move to the left 3 spaces, that's going to put me at -1. I can simplify that, and I'm going to get 2 as my slope. Now that was a very simple problem, but I wanted to review how you find the slope using the equation y2 minus y1 over x2 minus x1. Hopefully that clarified some things for some people who are still having trouble with that equation. And it's here so you can go back step by step. Now, although I'm getting ready to erase this so that I can move on to the slope-intercept form, this is a video, so you'll be able to rewind it and go back and replay it as you need to. Okay. Now, let's review slope-intercept form. Like I said, 3 out of the 4 classes, you guys have what in the world has happened? Hold on, technical difficulties again. So, like I said earlier, 3 out of the 4 classes learned slope-intercept form using a chant, so I think you probably remember that. But slope-intercept form is y equals mx plus b. Okay? Now, the m and the x are beside each other without any parentheses or anything. That means multiply. That's like m times x, okay? In this equation, I'm going to erase this. M is the slope. X is the input. B is the y-intercept. And y is the output. So, common errors. A lot of times students will see an equation in this form, and I'll say, what's the slope? And let's just say I have y is equal to 3x plus 9. I'll say, what's the slope? And they'll say, it's 3x. That is incorrect. That is incorrect because x represents the input. So I can't use 3x as my slope. Three x is not the slope. 3 is the slope. And what 3 as the slope means is if I go up 3 spaces and to the right 1 space, I will find the next point on my line. And I can go up 3 over 1, up 3 over 1. Well, I guess that wasn't really 1, so I should take that back. So, example, without using a grid, I could go up 3 over 1, up 3 over 1, up 3 over 1. And this is going to be a point on my line. Let me change the color on that. This is going to be a point on my line. This is going to be a point on my line. And this is going to be a point on my line. Every time I go from one point to the other, start on one point, go up 3 into the right 1, up 3 into the right 1, up 3 into the right 1. That is how I'm going to create my line. So in this case, if I connect my points, and if this was on a grid, I would have a straight line. As you can see, I missed this point here because it's not exact. So, that in general is the slope-intercept form. Y equals mx plus b. The y-intercept, of course, that is where your line crosses the y-axis. Your x value is always going to be 0 when your point crosses your y-axis. Alright? So now, I'm going to get rid of this. Again, you can go back and replay it and hear all of this wonderful information.